Okay, so most of you know how to set up a Punnett square, and you know how to interpret a Punnett square, but the issues you're having is to answer the question correctly and to set up the parents based on the question. Okay, so I'm going to show you again how to do a Punnett square, and I want you to study this. And I am recording it so you can rewatch it if you need to. So in this question it says, in Cocker Spaniels, the dog, the allele for a black coat, its hair, is dominant, so they represent that with a big B, over the allele for a brown coat, so brown coat is recessive, which they represent by little b. If they don't put the B's or the letters, you just make up your own, okay? So, the question asks, what is the genotypic and phenotypic ratios? So they don't want the percentage, they want the ratio of the offspring. If a brown Cocker Spaniel, mom or dad, is crossed with a heterozygous black Cocker Spaniel, parents. So the key, big B, big B represents dominant. Little b represents recessive, which big B in this case is for black, B black, and little b is recessive for brown. And it tells you that right here. Black coat is dominant, brown coat is recessive. Okay, step 2, the parents. Cocker Spaniel, a brown Cocker Spaniel. So if it's a brown Cocker Spaniel, that tells you that parent 1 is what? Recessive. Okay, because in order for a recessive trait to be shown, it has to have 2 recessive alleles. Parent 2 is heterozygous black. And we all know heterozygous means different. So in this case, it's going to be big and little. Okay? This represents recessive brown. And this represents heterozygous black. Let's see, you can see my B. It's supposed to be a big B. Okay, step 3, you do the square, which you guys are familiar with, especially from the symposium. So parent 1 is little b, and you can put it either side. Parent 2 is big B, little b. Then we drop the letters in. This square would be big B, little b. Same thing. Then this is little b, little b, little b, little b. So what's the phenotypic, or excuse me, the genotypic ratio? So genotype, they're asking for the letters. So the ratio is 2 big B, little b's, dot, dot, that's how we show a ratio, to 2 little b, little b's. So that's the ratio for the genotype. For the phenotype, they're asking for the physical characteristics. Sometimes it's the same, sometimes it's different. Big B represents black. So it would be 2 black coats, dot, dot, to 2 brown coats. Recessive is brown. This one's brown. So that's the answer for the first one. Not so difficult, you just have to know what heterozygous means, genotype and phenotype mean. Alright, let's look at number 1. This is a dihybrid. So now we're going to be looking at 2 traits at the same time. Okay, so question says, the several pea plants with genotype big T, big Y, little y, are crossed with pea plants with a genotype heterozygous T and homozygous Y recessive, what percent, so now they want the percent, of the offspring will be expected to have the homozygous T and heterozygous Y allele combination. So we're not quite sure what T and Y represent, okay, but based on that, I'd say T is dominant for tall versus short. Little t would be short. So this is our key. And big Y would represent yellow, a yellow pea. Peas can be yellow. And so little y would have to be green. Okay, so in this case it's recessive. So that's our key. That's step 1. Step 2 is our parents. So they give you the parents. So the parents are genotype here, are cross with genotype here. So they actually give you the parents, which is nice. This would be homozygous dominant and a heterozygous yellow. That's what it would be if they did not give you the parent. This one would be heterozygous tall with homozygous green. Okay, but in this case they just gave you the parents. And in most star questions they do give you the parents. Okay, so TT Y crossed with homozygous heterozygous T and homozygous recessive Y. So those are our parents. Step 2. Step 3, we got to make the square. So here it's a dihybrid, so instead of 4 squares, we're going to make 16 squares. So you got to make a rectangle. 4 times 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay? And to remember, when we're lining up our parents, we have to remember to be happy. Or in math, I believe you guys been using the distributive property, which is great. Sorry. But I like to use the happy face. So, eyebrow. First one. Big T, big Y. Another eyebrow. Remember, we're making a happy face. Big T, little y. Nose, big T, big Y, and mouth. Big T, little y. All right, next parent. Again, remember to be happy. Eyebrow. Big T, little y. Eyebrow. Little t, little y. Nose. Little t, little y. And mouth. Make it happy. Big T and little y. Okay, and you do have to write neatly so you can distinguish between your capital and your lowercase letters because it means something. So when you drop your letters in, remember to keep the same letters together. For example, this would be big T, big Y, little y. Keep the same letters together. Big T, little y, little y. big T, big T, big Y, little y. Big T, little y, little y. Okay, this case is big T, little t, big T, little t, big T, big T. Okay, you could do it this way too. Big Y, little y, big Y, little y, big Y, little y. Okay, here, big T, little t, big T, little t, big T, big T. Little y, little y, little y, little y, and little y, little y. We're almost done, don't give up. Big T, little t, big T, little t, big T, big T. These are two big T's. And then they're all heterozygous Y. Big Y, little y, heterozygous. Big Y, little y. Okay, we're going to make it big T, little y, little y. Big T, little y, little y. And big T, little y, little y. Alright? So we finished our Punnett square. Okay, and then the question again. You need to go back. What percentage of the offspring will be expected to have homozygous tall with heterozygous yellow? So this is what they want to know. So we count. How many look like this? 1. Not that one, because it doesn't have a big Y. 2. Not that one. Not that one, because it has a little t. Has a little t, little t. Little t, little t. No, that one. This one. 3. And 4. So 4 out of 16 have this genotype. This allele combination. So we're going to reduce this. So we're going to divide the top and the bottom by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. Percentage-wise, 1/4. If you have 1/4 out of $1, you have 25 cents. And the answer would be A. 25%. So 25% have homozygous tall dominant and heterozygous dominant for yellow. Okay, so now what I want you to do is answer number 2 on your own and answer number 3 on your own.